Introduction to Engineering Mechanics. Engineering mechanics is a vast field of engineering. It is applicable for solids as well as fluids. Thus, we can classify engineering mechanics into two branches: solid mechanics and fluid mechanics. Solid mechanics is further classified into mechanics of rigid bodies and mechanics of deformable bodies. In case of mechanics of rigid bodies, we see that when a force is applied on a body, the body does not deform. But in case of mechanics of deformable bodies, when a force is applied on a body, the body deforms. The study of deformable bodies is also known as the strength of materials. Our study will deal with the mechanics of rigid bodies under the heading Engineering Mechanics. So for us, engineering mechanics is the mechanics of rigid bodies. Now let us understand the term engineering mechanics. The term engineering mechanics is made up of two different terms: engineering and mechanics. The term engineering refers to the application, whereas the term mechanics refers to the study and analysis of the forces acting on a body at rest or in motion. Thus, we can say that engineering mechanics is the application of these concepts of mechanics in our daily life. On the basis of the state of a body, engineering mechanics is further classified as statics and dynamics. Dynamics is further classified as kinematics and kinetics. Let us see how. Do you remember this game which you must have played in your childhood days? In this example, as we can see, the ball is at rest in the boy's hand, and the stones, which are piled up one after the other, are also at rest with their weights acting downwards. Over here, when we neglect the deformation of the ball and the stones, then they are referred to as rigid bodies. The mechanics which deal with the bodies at rest is known as statics. Now, to hit the stones, we need to throw the ball. When we throw the ball, then the ball is said to be in motion. The mechanics which deals with the bodies in motion is known as dynamics. To make the ball move, we have to apply some force on the ball, as a result of which the ball moves by gaining some velocity and acceleration. Finally, its impact hits the stones, which were at rest. Thus, force is the cause of motion of the ball. Now, if we neglect the cause of motion, that is, the force applied, then the branch of dynamics which deals with the motion of body without referring to the forces causing the motion is known as kinematics. Thus, kinematics deals with the velocity and acceleration of a body. But if we take into account the cause of motion, then this branch of dynamics is known as kinetics. Thus we can say that kinetics deals with the force, weights, velocities, and acceleration, etc. Now, on the basis of this example, let us check whether we are able to answer these questions. Question. Over here, which are the rigid bodies? Answer. Here, ball and the stones are the rigid bodies. Question. What happens when we apply more force on the ball? Answer. In this case, the ball will hit the stones with more velocity, as a result of which more stones will fall. Question. Why the path of the ball is parabolic? Answer. It is because of the fact that the weight of the ball acts vertically downwards at every moment of its motion. Now let us discuss engineering mechanics in our daily life. Engineering mechanics finds its way in almost each and every task that we do in our daily life. While drawing the water from the well, we use the pulley to reduce the human effort. While rolling the ground, we pull the roller instead of pushing in order to reduce our effort. We know that a thrown body always follows a parabolic path, so the player throws the javelin from a particular angle. The architects made the Howrah Bridge using the truss-like structure in order to distribute the load acting on it. Now it's your turn to identify engineering mechanics around you. Engineering mechanics not only drives the different branches of engineering, but also depends on them. This interdependence of engineering mechanics and other branches of engineering feed a number of important industries. Finally, let us end this introduction to engineering mechanics by paying a tribute to some of the important scientists who contributed in this field and whose work you will study in the ensuing chapters. Isaac Newton gave us the Newton's laws of motion. Albert Einstein came up with the theory of relativity. Lamy gave us the Lamy's theorem. Archimedes gave us the Archimedes principle or the law of buoyancy. D'Alembert gave us the D'Alembert's principle. Galileo Galilei gave us the news of the falling bodies. Pierre Varignon gave us the Varignon's theorem. We never know, someday maybe the boy sitting next to us will also contribute to this growing science.